Hello, my good people, my friends. I know you're okay and you're doing very well. This is Dr. Sirme. And before we go on to just have a very interesting demonstration on electrolysis, maybe I can say one or two words to all my viewers. One, it's to my student. Things are getting better and better, and I know you're enjoying watching my video clips or my videos that I'm posting here pertaining chemistry. What I urge you to do, kindly keep telling friends to tell friends so that finally a number of us may benefit. Uh, like I said before, take a video clip, ask questions, then say something about chemistry, something that maybe you feel like doing or saying. So send that video clip to me. Then I'm telling you, I will post it here and people will get to see you. Then there is the forthcoming contest. Students, you can also engage in the same. I will direct you what to do. So do not worry. Like at the moment, we having just students from one station. Then you're going to see what exactly are you expecting in that luminous chemistry star competition. And to my other friends who are not necessarily students, the initiative I had towards helping some needy students has picked. And I want to thank everyone, especially those who sent their school fees or the money towards the paying school fees for this student. And the student is very grateful. Towards the end of this video, I think I'll post the student. I'll just let the student say a word. So kindly watch the video to the end. Thank you even for those who have sent their video clips. They are not necessarily students. Especially one of my mentor, my high school principal, who made me who I am. Mostly in my next upload, I will have to include that video clip from one of my mentor, Mr. Mwangi.
Hello guys, I am Francis Mwangi Jeroge and I've known Dr. Sirme for over 18 years. He's actually the best.
Thank you so much. Thank you so much, and welcome to Electrolysis. Welcome to another Dr. Sirme chemistry demonstration. And as I promised before, I will keep teaching you chemistry, and I'll never tire to do that. Now, for today, we want to do electrolysis. And electrolysis starts all the way from Form 2. Topic number 5. That is effects of electric current on substances. And in Form 2, you did study binary electrolytes. These are electrolytes that do have only two types of ion, a cation and an anion. Mostly ionic melts, that's molten ionic substances like molten lead-2 bromide, molten lead-2 chloride, molten aluminum oxide, among others. But when you come to Form 4, because I want us we concentrate with electrolysis of aqueous electrolytes. That is now the other type of electrolytes. These are electrolytes that now contain more than two types of ions, and these are solution. Remember, if you dissolve a solution, salt in water, there will be some ions from the salt and some ions from water. And before we even do anything pertaining to electrolysis, we need to understand the simple electrolytic circuit. A simple electrolytic circuit consists of the dry cells. These are the batteries. The batteries will be, this is the electron pump. We usually call it the electron pump, the source of the current. And of course, I can see this is the positive end of the battery, and this is the negative terminal there of the battery. Then I have an ammeter. The ammeter will help me confirm the current, the flow of the current. And as you can see, the reading is at 0 as per now. The positive terminal of the battery goes all the way through the ammeter to an electrode. Like I'm using this one, if it is a positive terminal of the battery, this would be the anode. It is called the anode. The anode is the electrode connected to the positive terminal of the battery and acquire the positive charge. Simply we say it's a positively charged electrode. We are using graphite. Maybe you ask yourself, why graphite? Graphite is a good electrical conductor. That's one point. Graphite is non-reactive. We say it's inert. It does not react with most chemicals or electrolytes, and it is cheap. Graphite is simply carbon, and it's very cheap. So on the other side, we have the cathode connected to the negative terminal of the battery. Okay, maybe before I proceed, I want to describe to you how the electrolytic circuit will look like ordinarily, maybe in a question paper. As you can see, there are the two electrodes. Mostly we use the graphite electrodes that will be dipped into the electrolyte. The electrolytes, of course, will have the positive and the negatively charged electrode. All the way it is, we have now the conductor going through the switch and into the battery, or rather the dry cell, provided we have a source of direct current. Then through the ammeter, and the circuit is complete on the right hand side. If you consider the battery, the positive terminal is always represented with the longer bar. So even if it's not labeled, the longer bar will always represent the positive. And of course, the shorter bar, as it is drawn there, will represent the negative. The flow of electrons, that is something you need to be very conversant with. And the flow of electrons, the battery, the positive terminal of the battery will attract the electrons in. And of course, they will be repelled. Remember, like charges do repel. So they will be repelled out of the negative terminal. And that means the dry cells, it's the electron pump. What do you call the electron pump? And maybe another way to describe the flow of electrons is just to consider what exactly happens at the anode. At the anode, this is where the negatively charged ions, that is the anions, migrate to. And when they migrate to the anode, they lose electrons. When they lose electrons, free electrons cannot survive or thrive in an electrolyte. So what happens? The electrons will flow out. That is, from the anode, the electrons are flowing out, or they are being attracted by the battery. Then, of course, at the other electrode, that's the cathode, that's where the electrons now will be gained. That is, at the cathode, that's where we have reduction taking place. At the anode, it is the oxidation taking place. So the loss of electrons from the anode flows through the external circuit all the way to the other side where there is the cathode. Okay, remember, instead of the ammeter, you can still use a bulb, or rather you can use a voltmeter, because the functioning of the ammeter is basically to monitor and even confirm that the current is flowing. Then of course the circuit is now complete. What will happen at the anode and the cathode is as I am describing. So with this, we are doing electrolysis of aqueous electrolyte. Like this is aqueous copper 2 sulphate. So you have the cations, the positively charged ions, copper from the soil, that is copper 2 ions, and you have hydrogen ions from the water. On the other side of the anions, you have the sulfates from the salt, and also you have the OH, the negative from the water. So what I'm going to do with this one, I'm going to start. We're doing electrolysis of copper 2 sulphate using graphite electrodes. Then we'd use the copper electrodes. So what exactly do I need to do? I need you just make an observation. Check on what is happening. This is my anode. The color, the appearance, you check on it. So I'm going to dip it into my electrolyte. Yes, I'll dip that is the anode. Then on the other side, I will dip the cathode. If you can consider here, there is a deflection. There is a deflection. That tells you a current is flowing. So with that, we're going to leave it for 2 hours also. Then we'll come back and make the observations. After some hours, I had to come back and do some observation. Remember, this is my negative recharged terminal. That means this is my cathode. The electrode here is the cathode. This is the anode that is connected through the ammeter to the positive end. This is the observation now for the experiment I did before. that is the electrolysis of copper 2 sulphate using graphite electrode. Okay, I want you to be very keen with what is happening at the anode. If you observe exactly, there are bubbles of a colorless gas. So as we'll be discussing the observation at the anode, there will be bubbles of a colorless gas. If I may look at my cathode, so you can see what has happened to the cathode. The cathode, remember the graphite electrode was black. It has been coated by a brown substance, As I had shown you before, when I started the experiment, there was some bubbles of a colorless gas forming at the anode. And the color of this electrolyte, as you can consider, it has lost the sky blue color. It has a fading blue color. So we're going to explain what exactly has happened in the following discussion. And maybe just to discuss that experiment, we have the copper 2 ions, the cations from the salt. We have the hydrogen ions from the water. We also have the sulfate ions from the salt and the hydroxyl ions from the water. Those are the two cations and the two anions. Now, with this, if I have copper 2 ions and hydrogen ions, and I'm using graphite electrodes, the copper 2 ions will preferentially be discharged, and they will gain 2 electrons at the cathode. That is, remember, at the cathode, that's where reduction is taking place to form the copper metal, and that is the brown coating that is forming on the electrode, that is the cathode. When we talk of the anode, at the anode, it is the hydroxyl ions that will be discharged, and 4 hydroxyl ions will lose 4 electrons, 1 for each, to form 2 moles of water, and a gas, that is a colorless gas, oxygen, is formed. That obviously we can see the bubbles forming there. So this is a half cell equation for the reaction taking place at the anode, and the other one taking place at the cathode. Remember, if you are to write the overall equation, first of all, you need to balance the number of electrons. So at the cathode, you must ensure that the number of electrons are 4. So you'll have 2 moles of copper 2 ions gaining 4 electrons in total to form 2 moles of copper metal. So overall, you have copper 2 ions, 2 moles of copper 2 ions, 4 moles of hydroxyl ions, then getting discharged, or both electrons, to form 2 moles of water, then 1 mole of copper metal, and 1 mole of oxygen. And kindly note this very important point. The color of copper 2 sulfate solution fades. It lost the sky blue color. That means the copper 2 ions are being discharged at the cathode and are not being replaced at the anode. On the other side, we are talking about the nature of the solution that will be formed. With the time, the solution becomes more acidic. And that means, because we are discharging out the copper 2 ions and hydroxyl ions, we are remaining with hydrogen and sulfate ions that combine to make now the sulfuric acid. I want to do electrolysis of copper 2 sulfate with the copper electrodes. And one factor that affects preferential discharge of ions, it is the type of electrodes used. So I have my electrolyte, copper 2 sulfate. I'm going to have the dry cells. Then I'll have an ammeter. Okay, therefore the 2 electrodes have been weighed, that is pre-weighing. If it is a cathode, it is 15.57 grams. The anode is 15.83 grams. This is my negative. If that is my negative, it means this will be my cathode. This will be my cathode. And remember what I've done before, it's to pre-weigh the cathodes, as I've shown you earlier. So that is my cathode. Then I will have my anode. I have my anode, and then I dip in. If you can consider, you can consider what has happened in the ammeter is a current has, the setup, the circuit is complete because there is a current flowing there. So what I'm going to do is to leave the experiment for like 2 to 3 hours. Then we'll come back to make the observation. That is electrolysis of copper 2 sulfate using copper electrodes. Okay, this is the electrolysis I did before, and this is the electrolysis of copper 2 sulfate using copper electrodes. And as you can see, this is my anode. This was my anode. I had already weighed, and it was 15.83 grams. Then this was my cathode. It was 15.57 grams. Now I want to make the observation. I want to observe that you observe what happened to the cathode. There is a brown coating that was formed, and what I'll do later is to weigh. I'll just weigh to see the change in mass. So this is what happened to the cathode. Basically, this is what happened to the cathode. Now, if I may consider what happened to the anode, you can check what exactly happened to the anode. The anode was worn out. Actually, we can say it was eaten up. So otherwise, the cathode was increasing in mass and the anode was decreasing in mass. I can go ahead and do the weighing. Remember, this is my cathode. Initially, it was 15.57 grams. I can do the weighing again and to see what exactly happened. The new mass here is 20.43 grams. So the cathode increased in mass. If I may weigh the anode, the anode initially it was 15.83 grams. Now I can do the weighing for this one. You can see there is a decrease in mass. It is now 11.26 grams. So the anode decreased in mass while the cathode increased in mass. Good. So next, as I've said, is to explain what exactly is happening. Another observation that I can have, it is my solution. Copper 2 sulfate solution remained blue. Maybe we need to go ahead and ask ourselves what exactly happened. So that is what we're going to discuss next. Maybe to discuss this one, we can go ahead and discuss this electrolysis of copper 2 sulfate solution using copper electrodes. Obviously, we need to start by identifying the ions present. The ion present remain copper 2 ions from the salt, hydrogen ions from the water, that's cations. The anions, the hydroxyl ion from water and the sulfate from the salt. Now, we need to discuss what exactly happens at the cathode. At the cathode, both cations will migrate to the cathode as usual, but copper 2 ions again will preferentially be discharged, basically because it is lower in the electrochemical series. And of course, as that happens, the copper 2 ions are discharged and copper metal, that is the red brown, basically we say it's brown or red brown solids are forming at the electrode. Then the two observations, there will be that brown coat, and as I did before, you noted there was an increase in mass. So the electrode, that is cathode, increased in mass. On the other side of the anode, we have the hydroxyl ion and the sulfate ion migrating to the anode, but none of the two will be discharged at the electrode, that is at the anode. Because of the nature, we have changed the electrode, the nature of electrodes. Now we are using copper metal, and for that reason, instead of any of the two ions being discharged, mostly because like hydroxide, that's what is expected to be discharged, the copper metal, the copper electrodes will be dissolving. That is, the atoms in that metal will be losing 2 electrons to form copper 2 ions. And the observation, as we have observed, the anode will wear out. Then when we come to the mass, the anode will decrease in mass. Good. Going ahead, if you look at the other very important points, it's like we have observed the color of electrolyte remained pale, the blue, that's the sky blue. The reason for that is that at the cathode there is the discharge of copper 2 ions, but that is the copper 2 ions to become metal. But at the anode, the copper 2 ions are being replaced because the anode now it's dissolving, forming the ions. So there is a balance of electrons, of not electrons really, but there's a balance of ions inside the solution, the copper 2 ions, and therefore it retains the blue color. The concentration, of course, of the electrolyte remains. The concentration of the electrolyte remains because you are discharging copper 2 ions and replacing. This concept is so much applied in the purification of metal. You attach an impure metal as the anode and then a pure metal as the cathode. Then that help in the purification. Okay, before we wind up the electrolysis process, I wish we discuss briefly on Faraday's law. And this was a concept that was discussed, or rather it was brought forward by a guy called Michael Faraday. And Michael Faraday connected or tried to relate the quantity of electricity that we pass through as an electrolyte and the amount of substance that will be deposited at the cathode or the anode. Like for this experiment, I tried as much as I could and I maintained a current of 1.5 ampere. Then the experiment, the timing was 2 hours 44 minutes there. That is 98.40 seconds. Then, of course, as you have observed, we have done the weighing. We did the pre-weighing, then after, post-weighing. And the cathode, like if we concentrate with the cathode changed the mass from 15.57 grams to 20.43 grams. So if you do the difference, the amount of copper that was deposited at the cathode, it was 4.86 grams. Of course, if you consider the molar mass of copper, it is 63.5 grams per mole. Remember, like in this case, we'll be talking about quantity of electricity. Q, that is given in coulombs. See, the current will be given in ampere, that is the unit for this case, and time will be given in second. Now for this example here, we can go ahead and work out the quantity of electricity that was passed in this experiment. That is the 1.5 amperes multiplied. Remember, the quantity of electricity is given by current times time. So in this, it will be 1.5 amperes multiplied by 98.40 seconds, and you get 14,760 coulombs. With this, it implies that when this quantity of electricity was passed, that is 14,760 coulombs, 4.86 grams of copper was deposited. What if we want to deposit 1 mole of copper? That's how we argue out that first principle. What if we want to deposit 63.5 grams? So if you do the working as I've shown you there, it is the 63.5 multiplied by the quantity of electricity in the experiment divided by 4.86, the amount of copper that was deposited. And that gives you that figure there, 192,851.9 coulombs. That is when you deposit 1 mole of copper metal. Then you go ahead and ask yourself, what was the half-cell equation for the deposition of copper? It was copper 2 ions gaining 2 electrons for each, and then you get 1 mole of copper metal. And if you consider that it is 2 moles of electrons, that is translated to be 2 Faraday. It is 2 Faraday. Then you argue out if 2 Faraday is equivalent to that big figure that you see, 192, that one. What about 1 Faraday? So you will go ahead and do the division and you get 96,428 for this experiment. And this one is what we call the Faraday's constant. Well, for my case, it may be slightly lower because of obviously the experimental errors, but the exact figure is as I've given there, 96,485.3365 coulombs per mole. And this one can simply be approximated. You can approximate it to 96,500 coulombs. Basically, what is this constant? This is the quantity of electricity that is passed through an electrolyte for 1 mole of electron to be used. Either it is gained or lost at the other side of the anode. So this one is basically a sample question on Faraday's law. Maybe you ask yourself, which are these quantities and areas they will ask you questions? You can be asked to determine the mass or volume of a substance that was deposited either at the cathode or the anode, quantity of electricity, that is Q, amount of current, time taken during an experiment, that is an electrolysis experiment, the charge of a given ion. You can be asked to find the Faraday, the number of Faraday, that is again connected to the charge. Or rather, you can be asked to write a half cell reaction. And kindly do not forget, we have a program, we have a project to support a student who will talk to you. You get to understand who exactly are we supporting, and I'm very sure you will agree with me that this girl needs support. I told you the girl lost her father last year, that's October. Then I talked to her mother just recently, and actually she's undergoing training. I asked her, at your age, she's like 50 there, at your age you want to learn? No, she told me, I want to do something to do with the home management. Then somebody has promised some job, maybe in Middle East. That one truly touched me, because at her age, because she has this girl as the second born, there are other 3 kids, some are in primary as young as 4 years, and this person is from hardship area. So definitely, as I judged from my perspective, this lady needs to be assisted, and we are not going to do much. We're just going to help pay school fees for this student in Form 3. Very little. I gave you previously the school account number. I also gave you the admission number, how you're going to pay the school fees for this girl directly from your M-Pesa. And that would be very good of you. Then, of course, you'll forward that M-Pesa message to my WhatsApp number, the one I've given you there. Or rather, I'm very sure immediately you pay, the amount you pay, it's reflected directly into the school's account. May God bless you so much. God bless you so much.
Hi everyone, I'm Tricia from 3. I want to thank you all for agreeing to help my mother pay my school fees, and may God bless you all. I promise that I will be a good student and a hardworking girl. May God bless you all.